Okay, so what is stoichiometry? Let's define it before we talk about how we use and do a calculation. So what is stoichiometry? So it's just predicting the quantities in a chemical reaction. So if I'm a chemist and I'm trying to make some chemicals, if I want to produce so much of it, how much do I need to start with? So if I'm trying to produce water by combining some hydrogen and oxygen, how much hydrogen and oxygen do I need to make like 20 milliliters of water? Right? Which you'd probably make more than 20 milliliters, but. Or if I have these two amounts of chemicals left, how much can I make of my product in the end? So that's what we're going to be doing with stoichiometry, predicting how much you can make or how much you need to do a certain reaction. So we can think of it with this example. So let's say we're trying to build a bike. And in the warehouse we have maybe 5 frames, maybe 10 wheels, 3 seats, left maybe we have 6 handlebars, and let's say 15 gears. So how many bikes can we make if these are what we have left?
3.
We can make 3. So why 3?
Because there's only 3 seats.
Correct. So there's only 3 seats. So we can only make 3 bikes. That would be our limiting object. Okay? So this is kind of what we do in stoichiometry. So if I have 10 grams of hydrogen and 10 grams of oxygen, how much water can I make? Okay? So when we do stoichiometry, we have to talk about a mole ratio. So a mole ratio is the moles of a substance to another mole of another substance in your reaction. So if we're looking at this reaction with water, if I have 2 moles of hydrogen gas, so here are my 2 molecules of hydrogen, and I have 1 molecule of oxygen, I can make 2 molecules of water. So these numbers are our coefficients. Remember there's a 1 here if it's not shown. And the 2 are called our mole ratio. So it's just a ratio of moles of one thing to moles of another. So if I have 2 moles of H2, it's related to 2 moles of H2O. That's our ratio of moles. Or we can write a lot of other ones. I can have 1 mole of O2 to 2 moles of H2. So that's the ratio of oxygen to hydrogen. Or you can relate 1 mole of O2 to 2 moles of hydrogen, or not hydrogen, water. Okay, so these are ratios of moles, and we always get them from a balanced chemical equation. So it helps us convert from moles of water to moles of another substance. So if you look on your little chart that I passed out, you'll see that ratio is listed here, where it says mole to mole. Okay, so we're going from moles of substance A, so let's say it was maybe hydrogen in this case. And we want to know how many moles, if we have like 10 moles of hydrogen, how many moles of oxygen would that be equal to? We want to use that mole to mole ratio. So from our equation it was 2 moles of H2 to 1 mole of O2. So you'd use those numbers to help us convert. Okay? So let's look at some mole ratios in this equation. So if we wanted to know the ratio of hydrogen to nitrogen, what would be our ratio? How many moles of hydrogen? 3. And how is equal to how many moles of nitrogen? 1. Okay, so that would be, we would use that conversion to go from hydrogen to nitrogen. What if we wanted the ratio from hydrogen to ammonia? What would be our mole ratio? So 3 moles to 2 moles. Okay, so we're just getting that from our balanced chemical equation. So all you have to do is look at that balanced equation. So first thing, whenever we do one of these problems, is going to be make sure your equation is balanced. And I reminded you to look there. If you look on your chart, it says use the coefficients from your balanced chemical equation. Okay, so what are the steps to do a stoichiometry problem? So first step is to make sure your equation is balanced. So that's what we've been practicing, how to balance those. Then determine what do you know. So what are you given in the problem? Okay, then you want to figure out what do you need to find. So what's the unknown? And then you're going to use your map to get from one side to the other side. So make sure your equation is balanced. What are you given? What do you need to find? Use the map to get there. So we're going to set up our little conversion kind of tracks like we did before. Okay. So you always start up here. You put in your conversion for the next one. Remember, what does bottom mean?
Divide.
Divide down here. On top means?
Multiply.
Multiply. Okay. So you always put what you're given in the first blank. Then set up your conversions according to your map that we follow. Okay, so let's look at the map a little bit more closely. So here's our map that you were given. So we always are going to start on the left side and figure out where we're starting. So this is our known side, okay, of our first substance. So if we're given mass, we'll start up here. If we're given a volume, we would start here. If we're given particles, remember, what is a particle? A particle can be an atom, ion, molecule, are the most common ones. Or we could be starting at moles. So you've got to figure out which one of these four areas are we starting at. Okay, so if we're starting at mass, we would divide by our molar mass of our substance first to get to moles. If we were starting at volume, we would divide by the 22.4. If we're starting at particles, we would divide by Avogadro's number. So I put that there to help you remember where it should go. Okay, then we're going to use our mole ratio to go from our one substance to the other substance. So we use our equation. And then finally, maybe we want to end up at a different unit besides moles, so we may have to do one last step. So we may have to use mass, so we may have to multiply by the molar mass of our new thing, or multiply by the molar volume, or multiply by Avogadro's number. Okay, so let's try one. There we go. So if we have 2.2 moles of potassium chlorate, and it reacts, how many moles of O2 will be formed? Okay, so if we have 2.2 moles of potassium chlorate, how many moles of oxygen will be formed? So when I come across a problem, I always like to write what am I given, what do I need to find underneath my equation. So I'm given 2.2 moles of potassium chloride. So I'm given this substance. So I usually write it underneath what it is. And I need to find moles of oxygen. So this is my unknown. I need to go to oxygen, and it needs to be in moles. So I'm going from moles of one substance to moles of another. So we always start our conversion with what we're given. So we're given 2.2 moles. And now it's going to be important to actually not just write the unit, but write what it is. Because now we're talking about different substances. So it's KClO3 that we're starting with. So let's look on our map. Where are we starting? So we're at moles of KClO3. So we're at our known substance, so we're at moles. So we're starting here on this one. And what unit do we need to get to on the other side? We also need to get moles. So look, this one's just going to be a one-step problem. We have step number 1, use our coefficients. So moles of one thing to moles of another. Okay, so we have to use our numbers up here. So our coefficients, we're going to be using potassium chlorates, and we're going to use oxygens. So if we have moles of KCl3, what should go on bottom in the next step? What unit? If you want to get rid of it, we have to divide by it on bottom. So we're going to put moles of KClO3 on bottom, so they'll cancel. And then we're going to put moles of O2 on top. So here's our mole ratio. So how many moles of O2 do we have in our ratio? We have 3. Use its coefficient. And KCl3, its coefficient is 2. Okay? So we've canceled moles of KClO3. Now we're moles of O2. So that's what we needed to be in. So it's just a one-step problem. So we can calculate that. So we're going to multiply by 3 and divide by 2. Okay, anyone get an answer?
3.3.
Yep, 3.3. And it's moles. And then now you also have to tell me what substance, because we have more than one. So it's moles of O2. Okay? So does everyone understand why we put the 2 moles of KCl3 on the bottom and not on the top? What we're starting with here, if we got to get rid of it, we got to divide by it. Just like in math class, if you want to move something, you're multiplying, you divide by it. So if this was like moles of O2 on top, we would want to put moles of O2, so the 3 would go on bottom if it was that way. Okay, let's try another one. So if I have 0.0045 moles of KCl, how many moles of KClO3 were used? Okay, so same reaction. So I'm going to list what I'm given. So I'm given 0.0045 moles of KCl. And I need to find moles of KClO3. So I'm in moles. I need to go to moles. So again, I'm starting in moles, and I'm ending in moles, but of a different substance. So I got to use my coefficients again, just a one-step problem. Okay, so always start with what you're given, 0.0045 moles of KCl. So I have to use my coefficients, but I don't know which one to plug in yet. So what unit should go on bottom in the next step? KCl. So if it's on top, it goes to the bottom in the next step. So that means my moles of KClO3 go on top. So that's what I need to get into. So what are the coefficients that we plug in for both of those? So 2 for KCl, and then what about KClO3? Also 2. So if you multiply by 2 and divide by 2, what would be our answer? Yep, it doesn't change it in this case. Moles of KClO3 this time. So we're going to have the same number of moles because their ratio is the same. 2 to 2. Questions on that kind of mole to mole problem? Okay, normally we don't work with moles, we just use it to go back and forth. Normally we're using like grams or volume. So let's try a problem like that. So if we have 12.3 grams of KClO3, how many grams of O2 are formed? So this would be more like a normal problem we would see. If we have so many grams, how many grams can we make? So always list what we know. So we know we have 12.3 grams of KClO3. And what do we need to find? What substance are we looking for? O2. And what does our unit have to be for O2? It needs to be grams. So we're going from grams of substance A to grams of substance B. Okay, so let's look at our roadmap. How many steps do we have to do? So we're in grams of one thing, we've got to go grams of another. So remember, grams is mass, so we're starting up at our mass. Okay, and we need to go and end up where on the other side? We also have to end up in mass. Okay, so our first step to get to moles, we're going to use our divide by our molar mass. Second step, then we're going to use our coefficients. And then last step, we're going to multiply by the molar mass of the new substance. Okay? So divide by the molar mass. We have to find out the molar mass of KClO3. How do we find molar mass again? What do we use to find molar mass? Periodic table. So we have 1 potassium, which has a mass of 39.10. We're going to add it to a chlorine, 35.45. And then we have 3 oxygen. So what do we have to do with oxygen's mass? Multiply it by 3. So our molar mass would be 122.55 grams. Okay, so our chart said divide by our molar mass, so we're going to put that on the bottom. So 122.55. And it says opposite molar mass goes our 1 mole. So I put my 1 mole of KCl3 on top. So we've canceled the unit of grams. Alright, so step 1 done. Now on to step 2. So now we're in moles, and we need to go to moles of our new substance. So we've got to use those coefficients. So what unit should go in bottom in our next step? Yep, so it's on top here, goes to the bottom in the next step. And then what we're going into goes on top. So moles of O2. So our chart says to use the coefficients. So we got to look for the coefficient of KClO3, which is 2. And the coefficient of oxygen is 3. Okay? We can't stop here though because we're in moles now. We need to get to grams. So 1 more step. Okay, so now we're in moles. We're going to have to use our molar mass to get to, multiply by it to get to our new masses, new mass for oxygen. So we're in oxygen now, so we got to find the molar mass of O2. It says multiply by it, so it has to go on top. So it would be the molar mass of oxygen. Yep. Times 2 in this case, there's only 2 of them. So we get 32 for its mass. Okay, so grams cancel with grams, moles cancel with moles of KCl3, moles of O2 cancel. We're left with grams of O2. So now we can calculate. Remember, any number on top means multiply, any number on bottom means divide. Doesn't matter what order you do them in. So I would type in like 12.3, maybe times by 3, times by 32, and then I'd hit divide by 122.55. I'd hit divide again by 2. And so we can keep looking at our number, we can keep 3 numbers in our answer. Anyone get one?
4.82.
4.82. It's grams of O2. Okay. Anyone have questions as to where we found a number, why we plugged it in like this? Okay. Let's try one more. Why don't you try this one on your own? See if you can set this one up and solve. So we are given 19.8 grams of O2. We need to find grams of KClO3. So see if you can set this one up and calculate it. So grams of substance A to grams of substance B. So follow your math. Remember, if it's saying divide, you got to put it on the bottom of the chart. If it's saying multiply, you got to put it on top. Okay, let's set this one up. So what did we put on bottom in our next step? Ricky, what did you put on bottom?
32 grams.
Yep, 32 grams of O2. So we're starting in oxygen this time. So first step, divide by that molar mass. So we're going to put 1 mole then on top. Okay, and the next step, what do we put on bottom? Yep, 3 moles of O2. Comes from our coefficient 3. So moles of O2 cancel with moles of O2. And then on top we put 2 moles of KClO3. What we're going into. So that means 1 mole KClO3 goes on bottom. And what do we put on top? Yep, it's mass. 122.55 grams of KClO3. So multiply by anything on top, divide by anything on bottom. What do we get for an answer? What'd you get?
25.
I had something a little bigger than that. Yep,
50.55.
there we go. 50. We can keep 3, so 50.6 grams. Maybe forgot to multiply by that 2. Okay, any questions on that? So if we're going to a volume, instead of putting a mass in, we'd use that 22.4. Let's maybe try one of those, and then I'll give you time to work on your assignment. Okay, so let's try this one. If we have 4.53 grams of KClO3, how many liters of oxygen will be formed at STP? What does STP stand for again? Standard temperature and pressure. Okay. So we're given grams of KClO3, so 4.53 grams. And we need to find liters of oxygen. So that would be our unknown. So if we look at our roadmap, we're starting in grams. Remember, that's a mass. We're starting up here. And we're ending in liters, or volume. So we're ending down there. So first step, like normal, we've been doing, using our molar mass. Step 2, we're using our coefficients. Step 3, we're using our volume, so 22.4. Okay, so start with 4.53 grams of KClO3. So Austin, what would we put on bottom in this next step? So we're right here, so we're going to use this conversion. So what would go on bottom?
Molar mass of KCl.
Yep, and we found that one already. It was 22.55 grams. And then according to our chart, it says 1 mole goes on top. Okay, so now we're at moles. We need to use our coefficients in our next step. So Robert, what would we put on bottom? Yep, so we're in KClO3, so we need to put 2 moles KClO3 on the bottom. And what would go on top? Yep, 3 moles of O2. So our mole ratio. And last step, this time we're going to liters though. So if we look on our chart, we're using the 22.4 and we're multiplying by it. So where does that 22.4 go? On top. And our 1 mole goes opposite. So grams cancel with grams, moles and moles. And we're left with liters of O2. Anyone get an answer? What'd you get?
1.24.
Yep, 1.24. And our unit is liters of O2. Okay, any questions on those? Do you want to do another one together? We feel okay? Okay.